Hello everyone, welcome to the 8085 programming series. In today's session, we'll study some program related to the memory operations. So this is the first one. Calculate the sum of series of numbers. The length of the series is in memory location 4200H and the series begins from memory location 4201. So we need to add some numbers which are there in memory location. And how many number are there? It is stored in 4200. So 4200, it stores the actual count. So if it has 5, so we need to add 5 numbers starting from 4201. If it is 10, then we need to add that particular numbers which are starting from 4201. So in this case, consider the sum to be 8-bit number, so ignore carries and store the sum at memory location 4300. So we assume that the sum would be of course 8-bit, and if there is any carry, we will ignore the carry. So this is the particular program. Okay. We will execute it on the simulator, and I will show what is happening at each and every step. So this is the complete program. Let us execute on the simulator. So we are into the simulator now. This is the code, all the instructions making of the program, and here I have entered the data. So at 4200, I have entered 05. It means we need to add the 5 numbers which are coming from the next memory location. So there are the number of count we have to add is 5. So there are 5 numbers we have to add. If here if it had been 10, then we'll get 10 numbers. So there are 5 numbers, and the numbers start from the immediate next memory location. So we will add 4201, the data at 4201. So all this data, all the 5 data bytes will be added. So 2 plus 2, then plus 3, then plus 1 plus 1. So this makes up to be 9, because 2 plus 2 is 4, 7 plus 3 7, 8 and 9. So we will get 09 at 4300. So let us execute step by step. So with the first step, we initialize the memory pointer to 4200. So LXI H4200 stores 42 in H and 00 in L, and it also acts as a memory pointer. Next step, what we do is we transfer the contents of memory to register C. So move C, transfer the contents of memory to C, and memory is pointed by HL register pair. So HL contains 05. This is our count. So this count is actually transferred to register C. So this is we have in C. Now with the next step, XRAA. So this XRAA, what it does is it actually clears the contents of register A. So it may happen that register A may have some data. We need to clear the data. So this XRAA, XORing A with itself, it clears the contents. It makes A as 00. Then with the next step, INXH. So we were at 4200. So we need to fetch the first number, which is at 4201. So we are doing INXH. So with INXH, we can see H becomes 42 and L becomes 01. So we go to the next memory pointer, next memory, that is 4201, and we perform the add M operation. Add M adds the contents of register A with the memory which is pointed by HL. HL is pointing to 4201, and there we have 0, 02. So A is 0 and 02 plus 0 is 02. Then so first data byte we have added. With the next DCRC, we decrement the count because first number is added, so the count becomes 4. And then with the next step, J and Z, we check whether C is 0 or not. So because 0 flag is reset, it means C is not 0. So we are giving jump if not 0 to 8005. Okay. So 8005, it will jump to 8005 and go to the next memory pointer, which is 4202. At 42, so this is 4202. And then again we perform the add M. So add M, it adds the contents of register A with the memory which is pointed by HL register pair. So A had 02, A contains 02, and now this 02 is added, so this becomes 04. Okay. Then we again decrement C. So now C is not 0, it becomes 3. So 2 numbers are added, 3 numbers are left. So this will continue, this loop will continue until C becomes 0. And when C becomes 0, we have added all the data bytes. So let us run it. I'll just stepwise. Okay, you can just see what is going on. Okay, so we reach halt because for in the DCRC we got 0, and this jump instruction failed, so it comes out of the loop, and we have STA 4300. So here 430 we have 09. So if you add this 2 plus 2 plus 3 plus 1, we get 0, 9. So this is how we execute this particular program. Now let us go to the next one. Next we have this program. Calculate the sum of the series of numbers. The length of the series in memory location 4200H and the series begins from memory location 4201. So it is same as previous, just an extension. So what the difference is, consider the sum to be 16-bit number. So here we need to consider the sum to be 16-bit, not 8-bit as we considered in the previous case. So we need to store the carry also. So if the sum is suppose 16-bit number, then we must store the sum at memory locations 4300 and 4301. So this is what is the required thing. So least significant bits would come, first 8-bit, the rightmost 8-bit would come at 4300 and the higher order will come at 4301. So this is the required code starting from LXH, LXIH 4200 and all the other instruction as it is seen here. So these are the various instructions we are doing. Okay. So let us execute this code on the simulator, then I will explain each and every instruction. So now we are into the simulator. So this program is almost similar to the previous one where we added the data byte in the memory location. Only the difference is here we also need to check the carry and also take care of and also store that carry, so that the data becomes of 16 bits, not of 8 bits. So here what we do is we store the content in the data grid, that is the data. So at 4200 we store 05 to indicate that we are adding 5 numbers. So this stores the count, and the number starts, the actual number starts from the next memory byte, next memory location. So 4201 we have 15, then 25, then 20. I just entered some random numbers, and of course I have added them using the programmer calculator at hex, because this will add the hexadecimal in hexadecimal format. So the answer will be 1 2D. So this 2D will be stored in memory location 4300 and 01 will be stored in 4301. So this is the result we will be getting. We can store any data. So these are the 5 numbers will be added, which will be added. So let us execute stepwise. So with the first step, LXIH 4200, so HL will contain 42, HL will contain 4200, and they will also act as a memory pointer. With the next step, we transfer the data from memory location pointed by HL to register C. So this count 05 is stored in register C. With the next step, XR A, we clear the contents of register A. So in case if there is any data in A, that must be cleared. Otherwise, we won't get proper result. With the next step, we transfer the contents of register A to B. So we also clear the contents of register B. So B also becomes 00, because we will be storing the carry generated into register B. Therefore, we are making B as 00. Now we increment the memory pointer INXH. So we come to 4201. So we go to this. Next, with add M, we add the contents of register A with the memory which is pointed by HL register pair. So HL is pointing to 4201. The data is 15. So 15 plus A equal to A. So A was 00 and we added 15, so it becomes 15. Now with the next step, JNC, this JNC checks if carry is generated. So JNC means jump if no carry to 800C. So if carry is not generated, it will jump to DCRC, and if carry is generated, it will increment B. So as we can see, carry is not generated, so it will jump to directly DCRC. So we are decrementing the count. So one number is added, so we decrement the count, it becomes 04. And the next instruction JNZ, it checks whether C is 0 or not. So if C becomes 0, this will come out of the loop. So we are giving the instruction jump if no 0 to 8006. So 806 is this one, so it will increment H to go to the next number. So it increments H. Now HL becomes 4202 and the data at 420 is 25. So next instruction adds this M. So now it becomes 3A. Okay, again carry is not generated, as you can see carry. So this B is not incremented, again decrement C. Okay, so this continues. Okay, and we go on adding until the counter becomes 0. Okay, and if there is a carry, the carry, as you can see, carry is generated at this point. So now in this case, B will be incremented. As you can see, B is incremented, so B is incremented. Okay, and this continues until C becomes 0. After C becomes 0, So STA4300, what it will do, it will store the content of register A to memory location pointed by 4300. So this 430 becomes 2D, and then in the move A comma B, the content of B is transferred to A, because we need to store this content to 4301, and we cannot directly transfer the contents of B to 4301. So we transfer the contents from B to A, and then STA will transfer the contents from A to 4301. So this is the result for 2D 01 2D. This is what we got in the calculator also. Okay, so this is the result. Okay, so this is how we do this particular program. Let us go to the next one. Now this is the next program. Multiply two 8-bit numbers stored in memory location 2200 and 2201H by repetitive addition and store the result in memory locations 2300 and 2301. So there are two numbers, we need to multiply them by using repetitive addition. So what is the meaning of repetitive addition? Suppose we want to multiply a number, let us say 5 by 6. So we add 6 5 times. So that is what we do. So this is called as repetition, the multiplication by repetitive addition. So 6 into 5 same as 6 adding 5 times. So we'll do this, and the result is actually the result may be a 16-bit number. So this must be stored in these two memory locations. So one location will store the lower half 8 bits, the other with the higher half 8 bits. So this is the program. Let us I've entered the program into the simulator. Then let us execute this, and we need to store some data first. So let us do this on simulator. So this is the required program on the simulator, and these are the two data bytes will be multiplying. So we have to multiply 16 by 12. So let us use the calculator and check what answer we'll be getting. So if we multiply 16 by 2, in hexadecimal we have 18C. So this 8C will be stored in memory location 2300, and 01 will be stored in 2301. So the answer will be 018C. Now let us execute stepwise. So with the first step, LDA 2200, the first number 16, it gets stored in register A, and with the next step we transfer the contents of A to register B. So what our strategy will be to get these two numbers in register B and C, but we cannot directly transfer from memory to B and C. So we first transfer to A and then to B. With the next step, we take the next number LDA 2201. So because of which the number at 2201, that is 12, it gets to register A, and we transfer the contents to register C. So B has 16 and C has 12. Now next step, we clear the contents of register A. So we need to clear the contents of register A, because what we are going to do now is we will be adding 16 12 times. Okay, so if there is some data in A, then it will actually, because we cannot do addition without A, so we need to clear A, otherwise we will get wrong answer. Then with the next step, move D comma A. So we transfer the contents of register A to register D. D will store the carry in this case. So if we are adding the two, if we are multiplying through addition, and if a carry is generated, that carry will be stored in register D. Okay, so this part, all the initialization. Now next we add B. So add B adds the contents of register A with B. So we are adding 16 now. Okay, now this 16 will be added 12 times. Okay, so with the first one, now here after addition we check if carry is generated or not. If carry is not generated, it will jump to 800F. It will decrement C. Okay, so because carry, as you can see, carry is not generated, so it goes to decrement C. So now it becomes 11. Okay, now since here we are giving J and Z, so this loop will be executed until C becomes 0. So J and Z 800, so it again go to add B. Okay, so add B, so 16 again plus 16. So 16 was added once, now it is added twice, the second time. So 16 plus 6 is 32, but here we are, because we are doing hexadecimal addition, it becomes 2C. Okay, then again it will check for the carry. Carry is not generated, it will decrement C. So these steps will be repeated until C becomes 0, and as C becomes 0, we have added 16 12 times. Okay, so when it goes that, when we do that part, it will come out. Okay, as soon as C becomes 0, so now it becomes 3 2 1. Okay, now as soon as C becomes 0, okay, so next is STA. What STA does, it stores the contents of register A to memory location 230. So we have to store the lower 8 bits at 230. So this is the result 8C. Okay. And with the next step, we transfer the contents of D. So D is holding the carries, all the carries. So there is no whatever data is in D is the highermost 8 bits. So that is, so we transfer from D to A, and then subsequently to 2301. So STA 2301 ensures that the data from A is stored at memory location 2301. So this is the result 018C. So we did on the calculator, we got the same answer. So this next is how. So this is how we do this particular multiplication program. So that's all for this session. Thanks for watching.